Okay, we're doing a little bit of review before the big test on exponents and exponentials. There are so many different kinds of problems you really need to study tonight. You need to do a quality job studying tonight because this is not an easy test. You can do well if, I mean, we're not hiding anything. Like, we've showed you every kind of problem that you have to know how to do. But there's just so many places to make little mistakes. You've got to practice. All right, so be your best self as you study for this test tonight. You need more time than usual, and you need to be tough on yourself. Like, if you get one wrong, you got to really go over it and make sure you understand. All right, this one, to begin with, we have to understand that this means x plus 7 to the fractions powers have roots on the bottom, just like plants. That's the root. That goes on the bottom. So really, this says to the 2/3 equals 16. And then you have to know you're not multiplying it by 3/2. You're putting it to the power of 3/2. And then these will cancel, but you just did a square root of a variable here, so it needs absolute value of x plus 7. And don't just slap a plus minus on this answer over here. It doesn't work. Now I have to do square root of 16, which is 4, and then 4 to the third is 64. All right, now I'm going to split this into two equations. X plus 7 is 64. X plus 7 is negative 64. Final answer when you subtract 7 from both sides. X equals 53. No, 57. Is that right? Okay. And over here, minus 7 minus 7. X equals negative 71. Is that right? Okay, good. Okay, now if my life depended on it, I would check my answers. Now, this test is not a Marzano-style test where we have only 9 questions or 12 or whatever. This one's it's a full-size test, and it's given over the course of 2 days. So we told you it was Wednesday. It's actually Wednesday and Thursday. Okay, one part's with the calculator, one's part's without. All right, so the first test is coming tomorrow. And we wanted to get, the good part is we could have crammed it all into one day and you'd have been like frantic to try to finish, and we didn't. So you will be able to have time to take your time and check your work. Okay, so I've got, if my life depended on it, I'd check it. And also sometimes you get an answer that doesn't actually work. Okay, now let me check on this one. If I wanted to put in 57 here, I could take 57 and then add 7 and then square it and then take the cube root of it, and it better be 16. But I would rather do it in a different order. That's 64, and I could take the cube root of it first. Cube root of 64 is 4, and then square it, and gives me 16. See how that worked? Because again, you can do these in any order you want. You can do the root first and then square it, or square it and then do the root. But it's always smarter to make your answer smaller first. Yes?
Will there be a non-calculator part on the test?
Yes, there's a calculator part and a non-calculator part. Otherwise, if this had been a calculator part, I would have right away, when I got to right here, you could have graphed both sides and see all where they crossed. That would have been an easy way to do it. I mean, I know you guys aren't used to that, but you could have. And there's a lot of things you could do differently if you had a calculator. Main thing is you can do those nasty powers with the calculator. All right, but again, write this. I guess you wouldn't have done that much of that differently. It's just you would have probably done this on the calculator, and it would have gone a little faster, maybe. All right. Okay, moving on. I want to make sure that you get, what does this mean? Why don't you make a fraction exponent for it? It's really 5 to the something. What kind of root is this? It doesn't have anything there. Do you remember you saw things like this all the way up until this year? All your roots looked like that. What kind of roots are they? Square roots. So what little number is really supposed to be there? A little 2. Okay. So that's really like the square root of 81, which would be 9. So this is like the square root of 5 squared. Remember how the order doesn't matter? So I could take 5 squared, which is 25, and then take the square root of that, which would be 5. Or I could take the square root of 5. See, 5 square root, there's a little 2 there that we don't see. Square root of 5, and then go and square that. Square root of 5 times the square root of 5 would be 5. Either way, your answer comes out to be 5. But I asked you to write it as a power, fraction power. That's 5 to the fraction. The roots go on the bottom, and then this thing goes on the top. 5 to the 2 over 2, which is 5 to the 1, which is 5 again. Just trying to work you through like all the different ways these can go together. All right, so let's say I had this. 7 to the 2 square root of 3. What does that mean? 7 to the what? You should have said 7 to the 2/3 power. Raise your hand if you had that one right. Okay, good. Now, do you know that one in your head? No. Could you calculate or do that one? Yes. What do you think the most common mistake is when people put this in to their calculator? Yes. Correct. If you put in 7, power of 2 divided by 3, you get it wrong. You guys get that? Because your calculator is going to go 7 to the power of 2, which is 49, and then it's going to take 49 divided by 3. It doesn't know what you mean. You need parentheses here, otherwise you will get it wrong. Okay, next topic. Let's go with 32 to the, let me see, we can do the 5th root of 32 and then make it negative so it'll have a flip in it. And then why don't we do 3 there? How about that? Compare this answer that you have to the kid next to you that I paired you with. See if you guys get the same thing. Fifth root of 32 is 2. 2 to the 3rd is 8. And then you make negative power is not negative 8. It's 1 over 8. Raise your hand if you had that one right. Okay, good. Let's try a completely different kind. Let's make the bases the same on something like this. 2/3 to the 2x is equal to, let's just go with 27 over 8 to the 3rd. You want to make your bases the same. Once your bases are the same, it'll be easy peasy. Pause for a second while you try that one. All right, so I think you guys are done talking about this one. Let's see if you did it right. I personally would have made the base 2/3 because this side doesn't have to change at all that way. That's, if you can do it that way, it's awesome because it's so much easier and less likely to make a mistake. So then I know this has to be 2/3. Do you get these have to be the same base? Now I have to make this and this equal. And so you ask yourself, how can I make 2/3 turn into 27/8? I need to square it. No, cube it. 2 to the 3rd is 8, 3 to the 3rd is 27, and then I got to get it to flip -3. And now I just bring this 3 down here, and this 2x came straight down there. So, all right, so now that the bases are the same, 2x equals -9. 2x equals -9, and x equals -9/2 or -4.5. Raise your hand if you had that one right. Okay, good. All right, let's talk graphing for a minute, and then we'll talk real world. Okay, graphing. This graph right here, exponential what? Growth. Write me an equation for it. I know you won't know exactly what the base is, but take a guess at it. If you've learned anything about the word exponential, you know half of the answer. Exponential means there's an x in the exponent. There we go. And now all I have to figure out is what number to put in the little parenthesis. And it's probably, well, I know since it's growth, it's got to be like 1 plus something, right? So it could have been 2, How many of you use 2 there? That's a good choice. Could he said 1 plus 1? Yes. What's better about saying 1 plus 1 is now, if I ask you, or sorry, 1 plus 1, if I ask you what was the growth rate, you wouldn't have said 200% because that would have been wrong. If you have a 2 in there, you might say that. But if you see that this way, I bet you will say, what was the growth rate then? 100%. It's this right here. All right, so then that's growth. Would you just sketch me the opposite of that? Not growth, but the other thing? Make a sketch of what it looks like and write me the equation for that. And please compare it with the kid I paired you with for today. Okay. Did you say something like that? And then y equals, and the classic one is probably 1/2 to the x. Would that be smarter to write it as 1 minus 1/2? They're the exact same thing, but yeah, it might be, because that way you'll know the growth or decay rate easier. Because what if it's not just something as nice as 1/2? What if it's 1 minus, 0.35? You could have said 0.65, but 1 minus 0.35 is even better, because now you've got decay rate of 35%. Does that make sense? Okay, now let's do some actual graphing, like graph this. In general, I want you to use 2 techniques on this. One is the XY chart, and the other is generally what should this look like. Seconds ago, we knew that anything that had this is generally like that. And then you got to ask yourself, okay, well, it's been stretched and it's been moved, and you should kind of know where it is. But to start with, I would say XY chart it, get some points, and then just make sure they match up with what you know it should kind of look like. If it ends up making a smiley face, you did something wrong. Now, what are some points to pick? Anything that works nice. In this case, 0 works pretty well. But if it didn't, I just wouldn't use it. Pick points that work nice. You want to find 3 points that work nice. You need a minimum of 3 points. Pause for a second while you give that one a shot. Okay. Once you stick in 0, do you get that this turns into a 1, and then anything to the 1 power stays itself, so 1/2 to the 1 stays 1/2, and then you times it by 3. Half of 3, 1.5. Okay, so 0 comma 1.5, or 1.5, or 3 over 2. Raise your hand if you had that point right. Good. Next one, put in a 1 maybe. Okay, or maybe there'd be other things that are even better, but let me get this jump off here. I agree. -1 would be even smarter. I'll do -1. Okay, so I put in -1. -1 turns this whole thing into 0, and that's smart. But be careful. Common mistakeville. Some people think whenever you make this equal 0, everything turns into 1. It's just this turns into 1. Then you go 3 times the 1, and you have 3. So -1 goes with 3. Okay, now we're going to put in 0 and -1. Obviously, something in that neighborhood would probably be smart. So maybe, okay, I'll take your word for it. I'll try -2. So if I want to put in -2 right here, -2 plus 1 would be -1. And then, ooh, anything to the -1 power flips it. So that gets flipped, turns into a 2. 2 times 3 is 6. Yes. -2 comma 6. All right, so now I'm going to graph them. 0, negative, or 0, 1.5. You know what? I'm going to get a nicer graph up here. 0, 1. Oh, wait a minute. My whole thing disappeared. Coming on. Whoa, now I just did 2 mistakes there. Thus proving 2 wrongs make a right. Okay. I'm going to bring this over, and I have all kinds of issues going on here. There. Now I'm going to erase this graph there, and then do it on this. Okay. So 0, comma 1.5. Over 0, up 1.5. Negative 1, 3. Now what I'm getting at here is a really important point. Negative 2, 6. Does this kind of look right? That's what it's really important to check yourself, because like some kids get 3 points and the 3 points go like this and they just blindly trust it and they go, okay, so there's my graph. I mean, you can't just trust the dots that you get. You got to look at them and say, okay, could this be right? Well, do you agree that it sort of looks like decay? And now, do you agree it sort of looks like it's been stretched up and is a little steeper than other decays? Okay, possibly. It's hard to tell on a stretch. How about this move? Which way was that moved? To the left. All right, now I know that can be confusing, but if I started with my normal decay being kind of like this, and then I stretch it up, this part, the tail has to go stretched higher, and this is stretched, see, compared to normal. And then I move it to the left. See how when you move it to the left, it almost looks like it's not moving on the right part of it? Anyway, so yeah, that's a little bit hard to tell, but looks like it could be right to me. And we got 3 points. They all are making this nice curve. It's probably right. I was doing one before class with some kids that came in for extra help, and the dots we were getting were going like this. Dot, 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 and then dot. It was like, what? Knew something was wrong, and eventually after graphed enough points, can you tell that that's the one that's probably messed up? And it was. So anyway, moral of the story, don't just blindly graph points. You got to make sure they make some sense. And if it's supposed to be decay, then it should look like decay. All right, now let's talk about, we've done the top 20 kinds so many times, I think you're going to be fine with this, but let's just do one. Let me think now. There. A whole bunch of stuff's going to cancel and then rearrange, and then all of a sudden a little equation will break out. And hopefully on this kind you'd be able to use a calculator because it's going to have a weird power. Use your calculator when you're solving this one. If you need to borrow one of mine, feel free to do that. You'll also need the calculator for the next part, which is real world kind of problems. I'll pause while you give that one a shot. Here we go, just a quick for the people at home. I think the kids here are getting it. This goes up to the top and joins the other x to the thirds. But wait a minute, they aren't happy either, so they have to go down there. Okay, so now the 2 is up on the top still. The y is up on the top still. And now I'm just going to rearrange my x's. I'm not going to try to do everything at once. That's a classic mistake. These guys need to go up to the top, so there's an x to the 5th on top now. These guys go to the bottom, and that means there's an x to the 3rd on the bottom. And then these other 2 that were still here, and I never touched yet, they are there, y to the 3rd. And, oh, wait a minute, this y to the negative half, let's move him up to the top where he'll be happy. Or negative 2, sorry. Y to the negative 2 becomes y squared on the top. Now, let's see, if I put the y's together now, this y and this y, that would make y to the 3rd. And this is a y to the 3rd, and they'll all cancel. Do you get that the y's are gone? Okay, awesome. Now, let's deal with what we have left. 2x to the 5th over x to the 3rd. And that's like x to, that's like x. There's 5 of them, and there's 3 of them on the bottom. 3 of them will cancel. That's 2x squared is what's left. Equals 20. All right, now how do I finish it from there? Get the clump alone. So divide by 2. If you square root right here, you will be tragically messed up for the rest of the problem. Okay? You want to divide by 2. Then I can square root. And I have 20 over 2 is 10. And then I go square root, and I don't know what the square root of 10 is, so I'll just say x equals the square root of 10. So sad. You get all the way to the end of the problem and you screw up like that. What did they screw up? Plus and minus, because you did the square root of a variable, and therefore plus and minus 10. Square root of 10. Okay. Any questions about that one? All right. So now the real world kind of problems. I really like these because you can actually use them in the real world. You guys haven't been around long enough to start complaining yet about, back in my day, things were so much cheaper. But it'll happen to you. Because someday when you're like my age, cheeseburgers are going to be, you're going to be like dropping 20 bucks to go to McDonald's. You're going to be like, I remember when you could go to McDonald's and for 3 bucks you could get a meal. You know, it's kind of true. You could get a dollar meal or dollar menu drink and like $2 menu hamburgers, and you've got a small meal. You can get a meal for 3 bucks. And if, let's do this problem, if someday it costs you 20 bucks to get a small meal at McDonald's, and you'll be the one who's complaining about it, you could set up an equation that would figure out what rate it is increased. You just need to know one more fact from me. What do you need to know? How many years from now is it? All right, so let's say you're my age. So let's see, if you are, let's imagine for a moment 17 right now. I know not all of you are, but it'll work nicer. I'm 47. That would be 30 years from now. Okay, so 30 years from now is your number. The Happy Meal's gone from, well, not necessarily Happy Meal, but a meal at McDonald's has gone from, on the cheapest one you could get was about 3 bucks now, to the cheapest one you can get some days like 20 bucks. You'll be saying starting value is 3. And that's an important point. You're like, which one should I use as starting value? Whichever one happened earlier in the time. You know, if there was a timeline, whichever one happened earlier on the timeline, that goes here. And the end value always goes here. And this is always 1 plus or minus a rate to an x. So go ahead, fill in the blanks. I'm going to pause for a second while you give that one a shot and compare with your neighbor. See if you get the same percent. Oh, by the way, give me a percentage that has 2 decimal places. It's a percent. When it's all done, the percent has 2 decimal places. I'll pause for a second. Okay, you should have said the start value is right now, it's 3 bucks to go to McDonald's, get a cheap meal. Someday I said it would be 20 bucks to get a good meal. 1 plus the rate, we don't know what rate that is, but we do know it's going to be 30 years from now. Okay, so in 30 years from now, it'd be funny if this actually ended up happening. So if you divide by 3 here to get the clump alone, 20 divided by 3 is some not nice number. Like, say again? 6.67 equals, and this was 1 plus r to the 30th. Then you have to put that 6.67. Now, I want to warn you here. I think that was a repeating decimal, right? Don't try not to round till the very end of the problem, or you will get a different answer, and you don't want to round too early. So I'm going to put in a whole bunch of 6s. It doesn't take long. You're on the 6th key anyway with your finger, right? So go 6.6666. Just do a bunch of 6s. Okay? Then you put that to the power of 1/30th to get this thing cleared. Now, I do want to remind you that right now, technically, you just did the even root, which technically there means that there'd be 2 answers. In problems like this, one of those answers is extraneous. So don't even go there. Don't even do the absolute value on this kind of a problem. You can just go get the one answer that's going to work. Because the other answer wouldn't have worked. It'd be extraneous. You put it back in, and it's the opposite of what it should be. So, all right. So then, somebody help me out. What is 6.6666 to the 1/30th power? Yes, sir. Read about 5 decimals. 1.06527. Okay. Then that's 1 plus r, and then I subtract 1 from both sides, and basically that means this 1 goes away, right? And there we go. 0.06527. Now I said a rate with 2 decimal places. That would mean not these 2 decimal places, but those two decimal places. So should I say 6.52%? No, that number right there tells me to round it up a notch, 6.53%. Now, do I think inflation is going to go up 6% per year? Probably not, but there is a lot of suspicion that since the Fed has increased the money supply a lot, what they did is they recreated imaginary money. I know that doesn't seem possible, but that's what our government can do. They, instead of actually printing it, because you get that, right? We could just print a whole bunch of money tomorrow, right? And we could, like, if we doubled how much money was in America, we just printed a ton of it. Do you get all the value of the money then goes in half? Okay. So could inflation go up then because of that? Yes, that's kind of what happens then. So since we did that, but inflation hasn't gone up a lot of people are saying it's going to catch up with us someday because they've printed all this money lately. Now, they didn't actually print it. They just made it up digitally. But they made up a whole bunch of imaginary money digitally in the last, like, 4 or 5 years because our economy was shaky and they wanted to strengthen it. This isn't an economics lesson, but I want to bring that real world thing in. This could happen. We could have 6% inflation. We've only had about 2 or 3% inflation, but it could go up because they printed so much money. All right. So I think we've covered a lot of stuff that you need to know, and I can never be perfect on preparing you, but that's a pretty good prep. Now I'm leaving you with 2 things. Number 1, you should do your homework, which is the other side of that worksheet. You did the evens last night. I'm asking you to do the odds tonight. But I know this is asking a lot, but I really want you to do well tomorrow. You should also do the quiz that is sitting in Schoology. That's the one that you can use the calculator on. Okay, so I'm going to pause for a second and show you what I want you to do for tonight's homework. It's bigger than usual, but tomorrow when you take your test, I will not assign you anything new. You'll have no homework tomorrow night. So it's a bigger assignment than normal tonight. I'll pause while I show you that. Okay, and we're in this course, semester 2, Exponentials, 9, and here we are for the review worksheet. I want you to do this one all the way then. I had you do it half of it last night, do the other half, and then we did this quiz in class the other day. If you didn't get it all the way corrected yet, you can use the key right here to correct yesterday's little quiz. Make sure you understand all those. And then I am assigning this one also tonight. It's a review practice quiz, calculator allowed, and there's a key for it right there. I know it's going to be tempting, but don't look at the key until you've finished. That way you have a real idea of, do I know it well or not? Okay? Now I could just say you have to do that right now in class, but I'm letting you do them in any order you want, but get them both done as your homework for tonight. Sir? That is a good question. Let me pause for a second and figure that out. So, okay, just to verify on the recording here that on the testing, we're going to do the non-calculator part tomorrow. That'll be our first one on Wednesday. And there's one kind that was on the practice quiz and I didn't talk about, and I want to make sure you get how this works. If the number is negative like this, do you get, it's the same basic conundrum as this, -2 squared versus -2 in parentheses squared. Do you get that they give you different answers? If the negative doesn't have parentheses, it's almost like that's a separate thing. You do the squaring first and then you stick the negative on the answer. And so it would be -4 in that case. In this case, it'd be -2 times -2, which makes +4. This one comes out positive. This one, the negative is drifting off there and then it gets slapped on at the end, -4. Okay, same thing here. There's no parentheses on that puppy. That negative would be floating around out there. You'd do the whole problem, and then you'd stick a negative on the answer. Okay? So square root of 4 is 2. 2 to the third is 8. That makes it flip, 1/8. And then you slap the negative on it, -1/8. All right, just wanted to cover one of those with the negative not in the parentheses. Okay. Have a great day.